Yeah, welcome all of you to the today's session. A little delay because of internet problem. I'm very sorry for that. आप सबका स्वागत है today's class के लिए. I'm trying to speak in Hindi as well, as per the request of the audience. Anyway, so I've been discussing about population forecasting methods. Yesterday we started with the arithmetic increase method. We completed already. And we also saw geometric increase method. In arithmetic increase method, you have to remember only one formula. So arithmetic increase method. So what you have to work out based on census data. If at all they ask any question from this. Somebody saying that these population forecasting methods are not there in the syllabus. That is not true. They are there in the syllabus. Water requirements means it is included. Without population, you can't work out water requirements. Understood? So they need not mention. So Pn is equal to P naught plus N into X bar. This is what you need to remember. It is arithmetic increase method. Geometric increase method, we discussed it too. We wrote two formulae. Okay. So without census also you can work out, provided that if R bar is given to you, so R bar into N you can write. R bar is not given, you have to generate R bar. In that case, we use statistical equation R bar by 100 whole power n. So you can use any one of these two formulae, depending upon the given information. So when you are working out problem by arithmetic increase method, by using census data, what you have to work out? X bar. When you are using geometric increase method, by using census data, you have to work out R bar. That's it. Nothing is there beyond this. Then let us see the third method, incremental increase method. Incremental increase method. Okay. So normally arithmetic increase method we apply for old and settled communities. Geometric increase method we apply for young and rapidly growing communities. Where rapid growth is there, we can apply. But there are some communities where there is a confused trend of growth. Neither there is a settled growth or average growth, nor there is an exponential growth. Sometimes growth is positive, sometimes growth is negative. For example, you see the capital of Jammu Kashmir state, Srinagar. So if you see the statistics of population statistics of Srinagar, 60s, 70s, 80s, Srinagar was one of the most happening cities in India. So most developing cities in India because of tourism, because of it is a very popular tourist destination for all Indians. But after this 80s, late 80s and early 90s, so because of proxy work from our neighbor, so the growth of population growth of Srinagar has hampered. So many of the people left the Srinagar and they settled at some other remote places. That is called exodus. People leaving their native place, going elsewhere for better livelihood. So exodus happened. So because of that exodus, if you compare population growth rate, I am talking growth rate, population always increases, population never ever decreases. But growth rate, if you see Srinagar during 80s, 70s, 80s, 60s, growth rate was positive. But during late 80s and early 90s, even late 90s till 2010, so growth rate has drastically decreased. Such type of trend is there, then we have to apply incremental increase method. Confused trend. Sometimes growth rate is positive, sometimes growth rate is negative. People who are working in private jobs, their increments are given. Salary increments are based on their performance. Sometimes they perform beyond the expectations of the company, so more increments will be given. Sometimes they perform below the expectations. They don't meet the expectations of the company. In such case, instead of giving more increments, they get less increments. 1 year they get more increments, next year they get less increments. Such type of trend is there in the past. The best method to work out the future salary that he may get only by incremental increase method. It is not only for population, anywhere you can apply these methods. Okay. So incremental increase method normally applied. So this method is suitable for communities best for communities which shows the following trend of population growth. So we need to observe only this because we have got only census data with us. So for given dt, if dp1 is less than dp2 and dp2 is more than dp3, or otherwise for given dt, dp1 is greater than dp2 and dp2 is less than dp3. So sometimes population is increase in mode, sometimes population is rate of increase is decreases, sometimes rate of increase is increases. This kind of trend is there, we can apply incremental increase method. So this method is, it is an extension of arithmetic increase method. It is not, it is no different from arithmetic increase method. So this method is an extension of arithmetic increase method. That is improvement over that. Arithmetic increase method. Okay. So what we do is, the extra thing that we work out in this method is y bar, that is increment over increases. So future population forecasted based on increment over increases. Sometimes increment over increases are positive, sometimes increment over increases are negative also. So depending upon that we work out. So future population forecasted based on average of the increment over increases. Average of the increment over increases. So let us assume, let y bar be the average of the increment over increases. Then future population Pn is equal to, it is P naught plus n into x bar, this is arithmetic increase. The addition to this is n into n plus 1 by 2 into plus or minus y bar. So this y bar, the extra thing that has come into this calculation part. So this y bar, how to work out this average of the increment over increases. So that's the extra thing that you need to learn. So this y bar is worked out based on x values. So xi plus 1 minus xi, if you subtract, we get y values. Y bar is equal to, it is based on y values we work out. So y1 plus y2 plus y3. So y1 plus y2 plus dot dot dot. M values, m number of values are there by m. So using this equation we work out y bar. So y values how to work out. So y at any point of time is equal to, by comparing x values, xi plus 1 minus xi, we take these values, then with the help of x values we work out y values. So how to get x values? Yesterday we discussed. At a time ti population is pi, at a time ti plus 1 population is pi plus 1 for example. At time ti plus 2 population is pi plus 2 for example. So between these two time periods x value is equal to, suppose let us assume x1, this is between these two periods x value is x2. So x1 is equal to what? Pi plus 1 minus pi. x2 is equal to pi plus 2 minus pi plus 1. So like this x values we work out. Once you get x values, we can work out y values. So y1 is equal to, it is x2 minus x1. Like that we work out y values, y1, y2, y3, y4, like that n values. Then we take average value that is being used. So this value has got some symbol also. Sometimes y bar is positive, sometimes y value is negative. Suppose x1 is more than x2, then automatically y value is negative. If x2 is more than x1, y value is positive. That means if x2 is more than x1, increment over increase is positive. If x1 is more than x2, increment over increase is negative. So based on that we work out. Generally, rate of increase increases, increase is taken as positive. Rate of increase decreases, that decrease is taken as negative. Method will take care of it, you need not worry about anything. Sign is, you need not worry about the sign, automatically method will take care of it. Understood? So that's all, only formula you have to remember. So let us try one question based on this method. Okay. Yeah. The population of this is completed yesterday. Yeah. The given the population figure of a place is 50,000 in 1990. The average increase in population is 5,000 per decade, that is X bar, and average increment increase is 500 per decade, that is Y bar. So X bar is given, Y bar is given. Then the expected population of the place in 2020 AD will be. Come on, work out all of you. Come on, try. Try all of you. So what is given to you? That example, population in the year is given, right? Population in the year 1990 is 15,000, that is taken as P0. So population in the year 1990 is taken as population 1990. I will take it as P0. So which is equal to 50,000. I took P0 as 1990 population. Therefore T0 is equal to what? 1990. Then you are expected to calculate population in the year 2020 by this method. So population in the year 2020, that is taken as Pn. So Tn is equal to what? 2020. So X bar is given as 5,000 per decade. He has given per decade. And Y bar is given as 500 per decade. Nothing mentioned regarding this sign means it is positive only. If it is negative, we will give minus 500, something like that. 500 per decade. This is given as 500 per decade. X bar is given as 5,000 per decade. Okay. Therefore, n is equal to what? How to calculate n value? In terms of decades, Tn minus T0 by 10. So 2020 minus 1990 by 10. Don't count like this. 1990, 2000, 2010, 2020 means you will get 4. So that is wrong. So carefully need to work out. So it is 3 decades, after 3 decades. Don't count like this. 1990, 2000 like that will go wrong sometimes. So use the equations and work out. So that's all. You have been asked to find out population in 2020, that is population after 3 decades. So what is generalized expression? I wrote here. Generalized expression is what? This is generalized expression. Pn is equal to P0 into n into X bar plus n into n plus 1 by 2 into plus or minus Y bar. So population after 3 decades is equal to what? How I can write? So n is equal to 3 here. So wherever n is there, write 3. So it is P0 plus 3 into X bar plus 3 into n plus 1 by 2. So 3 into 3 plus 1 by 2 into plus or minus Y bar. So here Y bar is positive only. Plus 500. So if we simplify, plus Y bar this is. In this case, plus or minus Y bar. So P0 is 50,000 plus 3 into X bar is 5,000 plus 3 into 3 plus 1 by 2 into plus 500. Come on, simplify, we will get. So 5,000 into 3, 15,000, 50, 65,000. This is 3 into 3 plus 1 by 2. 4 by 2 means 2. 6 into 5, 3,000. So this is 3,000. 15,000. 3,000 plus 15,000. 18,000. So it is, answer is 68,000. That was the answer for this question. So this is ESE question. ESE question without calculator you have to work out. That's why simple things which you can manage without calculator. Just formula substitution. Just simply you can work out the things. Okay. Similarly, try one more question. How to work out X bar and Y bar. If X bar and Y bar is not given, you have to generate by using population statistics. By using population data, past population data, we try to generate this x bar and y bar. Both of them are variables. We work out. So once we work out x bar and y bar, it's simply formula substitution. Let us see one more question: how to generate x bar and y bar. Take this question. The population of a town is shown below: 1960, 1970, 1980, 1990, 2000. So always we need to arrange population data in chronological order. First to past to latest you need to add. You need to post the data in the table: 60, 70, 80, 90, 2000. Projecting the population by incremental increase method, population in the year 2020 would be. Come on, try all of you. So one more example. So what is given to you? Time, population is given. Okay, 1960, 1970, 1980, 1990 and 2000. This is given to you, right? 2,50,000, 4,80,500. 2,50,000, 4,80,500. 5,50,300. Keep calculators with you. If better practice with virtual calculator. 6,38,600. Then 6,95,200. So from this what you have to work out? X values have to work out. How to find out X values? PA plus 1 minus PA. So difference between these two values. Once you get X values, Y values you can find out. How to get Y values? Xi minus 1 minus Xi. That's all. So between these two, this is PA plus 1 minus PA. So it is 2,30,500 between these two, difference between these two. I am using calculator, you also try. So 5,50,300 minus 4,80,500. You also try, all should try. You should not be a mere spectator. If you just copy down the information, it is of no use. You have to practice. You have to involve in the class. You should find difficulty. You should feel the difficulty on your own while solving the problems. Then only you will be successful in exam. 5,50,300. So it is 88,300. See, now I am also working out along with you using virtual calculator. 6,95,200 minus 6,38,600. So it is 56,600. So this is how we calculated. These are the X values. Now to find out Y values, what we need to do? Lower X value minus upper X value to take. So that is 69,800 minus 2,30,500. So whatever you get, that is X1, Y1 value. So 69,800 like that minus 2,30,500. If you get positive value, positive. If you get negative value, take negative value. It is minus 1,60,700. Between these two, 88,300 minus 69,800. 88,300 minus 69,800. If I am wrong anywhere, you correct me. Don't hesitate. It is plus 18,500. Then 56,600 minus 88,300. So minus 31,700. Now can't you work out X bar and Y bar? X bar is equal to sigma Xi values by M. So which is equal to 2,30,500 plus 69,800 plus 88,300 plus 56,600. So this will give you X bar by 4. So X bar is 1,11,300. And what is Y bar? minus 1,60,700. You take all the y values, y1 plus y2 plus y3 by 3. That is y1 plus y2 plus y3. This is y1, y2, y3. Understood? You can also write like this, sigma yi by m. So minus 1 lakh, with symbol you have to take, with sign you have to take, minus 1,60,700 plus 18,500 minus 31,700. One lakh 60,700 plus 18,500 minus 31,700 by 3. So it is 57,966.66. So we got x bar value, y bar value. What is P naught? Among all these values, whichever is latest, that is taken as P naught. So this is P naught, then this become T naught. So how many decades are separated? You have been asked to find out in which year population in the year 2020. So you have been asked to find out in the year 2020. So Tn is equal to 2020. Therefore n is equal to, I'll take next sheet. I'll write in the next sheet. Okay. So therefore this n is equal to, so Tn minus T naught by 10. So you get number of decades, because x bar and y bar we calculated both of them per decade. This is also per decade, because population data is given per decade. So 2020 minus 2000 by 10. So you have been asked indirectly to work out population after 2 decades. So population in 2020 is equal to population after 2 decades. It is P naught plus 2 into x bar plus 2 into 2 plus 1 by 2 into plus or minus y bar. So we got P naught already, 6,95,200. Latest among all population data is taken as P naught. So P naught is 6,95,200 plus 2 times x bar. X bar is 1,11,300 plus 2 into 2 plus 1 by 2. 2 to get cancelled anyway. Plus or minus y bar. But y bar we got negative here. Understood? The y bar is negative value, minus 57,966.66. It is negative y bar we got, minus 57,966.66. So if we simplify, we'll get population in the year 2020. So minus 57,966.66 into 2 to get cancelled into 3 plus 2 into 1,11,300 plus 6,95,200. So I got almost 7,43,000. 7,43,900. This was the answer for this question. Is it clear to you? Is it clear to all of you? See the comment section, comments. If it is clear, then I'll go to next topic. Okay. Then next method is decreasing growth rate method, or decreasing growth of rate method. Anyway, you can pronounce it. Decreasing growth rate method. Okay. So normally we apply this method when cities fast approaches towards saturation at the fag end of the growth curve. See now, some of the cities in India also, they are fast moving towards the end. So they are like cities, all metros, Delhi, Calcutta, Mumbai, Chennai, all these 4 metros were crowded. There is no space available to accommodate any more population. So for such communities, we apply decreasing growth rate method. So they already saw all kinds of growth. So they are fag end of the growth curve. So fast approaching towards end. See now, myself is old person. So I am also fast approaching towards my, end means end of my career. I am at the end of my career. So therefore, I can't expect so many things in my life, isn't it? So once you reach the top of the top of your career, miracles will not happen. So life will be slowly, progressively it happens, and finally we depart from that job, isn't it? We retire from the job. Exactly same way a community also. So at the end of the exercise, I drew this curve. So in this portion, this is called saturation point. So to reach saturation, it takes time. So curve will be going like this and slowly reach saturation. So in this portion, when this cities like Mumbai, right, Chennai, all overcrowded, Delhi, Kolkata, right, all these metros are overcrowded. There is no more place available to accommodate any more population. Of course, population is increasing. Rate of increase is slowly decreasing. Rate of increase slowly decreases, finally reaches the saturation. For such communities, we apply decreasing growth rate method. Okay? So let us see how we can apply this method to work out future population. Understood now? So for us, what is that thing we need to observe? Every community ultimately reaches to saturation, but it takes time. So when it is falling in that zone of logistic curve, then we have to apply this method. Understood? So everybody finally ultimately retired from the job. Nobody will remain in the job forever, isn't it? One fine day you have to retire. So we don't find jobs. People will not give job. So we are asked to retire from the job. So exactly same way community also. Growth completely ceases. No much growth happens for a community. In such case, we apply this method. Let us see. So this method is best suitable for communities which are fast approaching towards saturation. That point you have to remember. IAS exam, this kind of conceptual questions they will ask. This method is best suitable for communities which are fast approaching towards saturation. How you know that? For us is only by observing the population statistics. That is, for given dt, so dp1 is greater than dp2, dp2 is greater than dp3. This kind of trend is there in the population statistics. Then comfortably you can choose decreasing growth rate method. Here also you need to remember only one formula. Okay. So future population Pn is equal to, in this case, so like geometric progression method, this is exactly in opposite way. So 1 plus r naught minus d bar by 100 into 1 plus r naught minus 2d bar by 100 and so on to 1 plus r naught minus nd bar by 100. This is a generalized formula. So extra thing that you need to work out in this formula is the d bar. So whenever we use decreasing growth rate method, d bar is a new thing here. So how to work out d bar? D bar is nothing but average decrease in percentage increases. What is d bar? Average decrease in percentage increase in population. Average decrease in percentage increases. So how to calculate d bar? D bar is equal to, so d values have to work out, d1, d2, like that. M number of d values we will get, divided by m, you will get that one. How to get this d value? D at any point of time is equal to compare r values, Ri minus Ri plus 1. If Ri minus Ri plus 1 is positive, population is decreasing at constant rate, steady rate otherwise. If Ri minus Ri plus 1 is negative, means instead of decrease there is an increase. So increase here taken as negative, decrease taken as positive, because it is decreasing growth rate method. So d values we work out by use with the help of r values. What is r value? Percentage increases. Okay. See now, population at time t naught. Okay, for example, population at time ti is given to you. Population at time ti plus 1 is given to you. Ti plus 2 also given to you. That is pi plus 1, pi plus 2. Using this, what you can work out? R values you can work out. So you can work out Ri and Ri plus 1. So using R values you can find out Di. Di is equal to Ri minus Ri plus 1. This is how you can have to work out. So this will be given in the question. This data will be given to you. So what extra you need to work out? R values have to work out like this. So D1, D2, D3 like that we work out. Finally we arrive at future population. What is Ri value? Change in population by original population actually. Sorry. How to find out Ri values? Pi plus 1 minus Pi by Pi into 100. Right? Percentage increase in population, Ri's. So with the help of R values, we can work out D values. So this is how we can find out future population by this method. Let us solve one question. If you solve question, things will be clear to you. Okay. Generally, one time in the exam they have asked this question, that too in IS, of course, that too in IS exam, I think. No, that question is not there. IS descriptive, they have asked that question. Nothing will be there, just it is formula substitution. Okay. So only D values you have to work out. I will explain you with the help of some data. I will try to explain you. The help of one example. Let me set a question. Let us try one question, okay? 1 minute. I'll get it. Yeah. let us try this question example. This question has been asked in IS exam. The census record of a particular town shown the population figures as follows. He has given like this: year and population. 1970, 1980, 1990 and 2000. Population is given is 80,000, 1,20,000, 1,68,000 and 2,28,500. Calculate the population at the end of next 2 decades. At the end of next 2 decades, that means population in 2020 by decreasing growth rate method. Come on, try. Just to expose you to the method, I took this question. So this is the data given to you in the form of table, statistical data. So using this data, what you have to generate? D values you have to generate. So I forgotten to mention here, what is that R naught? R naught is nothing but among all R values, which are is latest R value, that is taken as R naught. R naught is equal to latest known percentage increase in population. R naught is latest known percentage increase in population. Understood? Come on, let us see. Let us how to work out R naught and D bar. So let us see. Use it for this particular population data. So what to do? Let us open a table. TI, PI, 1970, 1980, 1990, 2000. So 80,000, 1,20,000, 1,68,000, 2,28,500. So RI values. So how to find out R1? 1,20,000 minus 80,000 by 80,000 into 100. So 0, 0 cancel. 3 zeros I took as a common. So it is 40 by 80, 50%, right? R12 minus 8 by 8. That way also you can write. So it is 50%. These percentages. How to find out R values? I'll write here. Pi plus 1 minus Pi by Pi into 100. So this we work out in percentages. 50%. Between these two, R2. 168 minus 120 by 120 into 100. (168 minus 120 by 120 into 100). So now it is 40%. Decreasing. Growth rate is decreasing. 50% growth rate was there between 70 and 80. 80 to 90 growth rate is only 40%. See now. So 228.5 minus 168 by 168 into 100. 0 zeros cancel out. 228.5 minus 168 by 168 into 100. Population may be increasing, but percentage is decreasing. It is 36.01. So these are the D values, R values. What is DI? It is RI minus RI plus 1. So latest among all these, P naught is taken as what? This is taken as P naught, this become T naught. So T naught is equal to 2000. Population in 2000 is 2,28,500 and R naught is 36.01. Then between these two, decrease is how much here? 50 minus 40. Then you will get 10% decrease. So D1 is equal to 50 minus 40, 10. D2 is equal to 40 minus 36.01. or almost 36 otherwise. You take 36, round it to 36. Okay, I have rounded it to 36. It doesn't make any difference. So this is D2 is 4%. If you round it to 36, this is 4%. So therefore D bar is equal to, so 10 plus 4 by 2, 7% decrease average. Okay, so that is, so you have been asked to find out after 2 decades. So 2 decades population in 2020 to 2000 is given, no? Population after 2 decades is equal to 2 times you have to write that equation, geometric equation with a decreasing rate, R0 minus D bar by 100, 1 plus R0 minus 2D bar by 100. So every time it decreases by D bar rate. That was the assumption here. You can see here, how many times you have to write? N number of times you have to write. If it is only 2 times, 2, 3 times, 3, n times it decreases. So what is P naught here? 2,28,500. 1 plus R naught is 36, D bar is 7 by 100, 1 plus 36 minus 2 into 7 by 100. Understood? So 36 minus 2 into 7 is 14 it is. So 14 by 100. 14 by 100 is how much? (14 by 100 plus 1). 1.14 into 36 minus 7, it is 29. 29 by 100 means it is 2.9. 29 by 100 means 2.9. 1 plus 2.9, 1.29. 1.14 into 1.29. Right only, no? Into 2,28,500. So it is 3,36,000. You can round it to 3,36,033. Like this. Understood now? Cross check the values. If I am wrong, you correct me, no problem. Sometimes we do go wrong. Yeah, 3,36,032, absolutely right it is. Clear now? So this is about decreasing growth rate method. Just how to work out D bar. So 4 methods. Among these 4 methods, you can expect one question from this method this year. I guess. Because for the long, this question has been not asked in GATE exam. So maybe this year chance is there. So I'll consolidate information. One more method is there. Of course, that is nothing is there, formula substitution. Let me write that method. Let me complete that method as well. It's called logistic curve method. So you see, arithmetic increase method represent some portion of logistic curve. This is logistic curve, complete logistic curve. But arithmetic increase method represent only constant slope, where slope is constant. Whereas incremental increase method, this is exponential growth method, represent this portion, so where slope is keep on increasing. Decreasing growth rate method, where slope is keep on decreasing like this. When slope is decreasing, decreasing growth rate method, this portion. When slope is increasing, geometric increase method. When slope is constant, then we use arithmetic increase method. Incremental increase, sometimes you can this kind of slope, sometimes you can this kind of slope. Sometimes it increases, sometimes it decreases. Confusive trend is there, we use that method. Okay. So none of the methods will give represent a complete logistic curve. Only portion of the logistic curve. But one mathematician known as Verhult, he gave a solution to the entire logistic curve, and he proposed one equation. Using that equation, we can find out population at any time without looking at the trend. Whether increasing trend is there, decreasing trend is there, constant trend is there. Without looking the trend, you can comfortably work out future population by using logistic curve method But to work out that, there are so many number of constants you have to evaluate first. To evaluate those constants, certain population data is required. Okay? 3 population data is required, spread at equal time intervals is given to you. Comfortably we can work out future population by using logistic curve method. So this is logistic curve. Logistic curve is a population growth curve. So this curve is represented by equation. So population at any point of time, PT, population at any time, T is equal to PT. This PT is equal to, it is saturation population by, so this is given equation, given by the equation. This T value we measure always from the beginning. Beginning is taken as 0. At the T time period, when you are working out population data, so population at T time period is equal to PT. So population at any time in future. Population at any time, at any future time, PT is equal to RPN, PT or PN, whatever it may be, is equal to, it is PS by 1 plus M into e power nt. So if you see this equation, so there are 3 constants you have to evaluate. These constants are, one is PS. This PS is known as saturation population. This saturation point. That saturation population is taken as what? This is a population versus time plot. Population versus time plot this is. So saturation population we take it as P naught. Oh sorry, PS. PS is taken as saturation population. Population at saturation. And beginning population is taken as P naught. Population at beginning is P naught. One more population data is available. You can evaluate these constants. So P naught is beginning, saturation is PS. So P naught to PS it reaches, finally there is no more further growth happens for a community when it reaches saturation. That's all. Isn't it? There is a maximum boundary, that is maximum population a community can accommodate. Beyond PS, no way. So it started P naught, end at PS. In between it is PT. At any point of time you want to work out. So this PS value you have to find out. PS is a constant, M is also constant, N also constant. Then by substituting T value in this, you can find out population at any time T. So to evaluate these PS, M, N values, 3 population data are required. When 3 population data is given to you, such that at the time T naught, population is P naught. At time T1, population is P1. At time T2, population is P2. They should be given such that T naught is taken as 0. Then difference between these 2 time periods is T1. T2 is taken as 2 times T1. Therefore, again time difference between these 2 is T1 only. So they are spread at equal time intervals. 3 population data are available. Then we can evaluate those 3 constants. M is equal to, okay, 1 minute. We can evaluate those 3 constants. Saturation population we can find out. Population at saturation is equal to, it is 2 times P naught, P1, P2 minus, it is P1 square into P naught plus P2 by P naught P2 minus P1 square. So using this equation you can find out. Understood? PS value. So once you get PS value, M value also you can evaluate. M value is equal to, it is PS minus P naught by P naught. PS minus P naught by P naught is taken as M value. So P naught is known, M value also can evaluate. N value also possibly can evaluate. 1 by T1 into Ln, it is P naught into PS minus P1 by P1 into PS minus P naught. So all these 3 values you can evaluate, N value, T value. So you have to remember these formulae, that's all. Nothing will be there. Then again by substituting in this equation you can find out population at any time T. Okay. So this method is ruled out for exam point of view because nothing is there, only big calculations. But ESE exam conventional paper they are asking questions sometimes based on this method. Okay, anyway. So beyond the scope of this exam, GATE exam and ESE objective exam, therefore it is ruled out. Anyway, it is my duty to explain you. So this many number of methods are there. I will consolidate all the information. So finally what you have to remember? Pn is equal to P naught into N plus X bar. The arithmetic increase. Pn is equal to P naught into 1 plus r bar by 100 whole power n. This is geometric increase, or otherwise r into n. This way also can work out. Incremental increase p naught into n into x bar into n plus 1 by 2 into plus or minus y bar. And decreasing growth rate method, p naught into 1 plus r naught minus d bar by 100. Like geometric progression, you have to write this r naught minus 2d bar by 100. Every time it decreases by d bar n number of times. R naught minus n d bar by 100. So these are consolidated. Rpn is equal to pt, which is equal to ps by 1 plus m into e power nt. This is decreasing growth rate method. This is arithmetic increase method. This is geometric increase method. This is incremental increase method. This is decreasing growth rate method. This is logistic curve method. That's all. You have to remember all this formulae, finally consolidation of all the formulae. So you have to prepare notes on your own, taking all these important formulae. This is logistic curve method. So generally, if at all they ask any question in GATE exam, that is between geometric and incremental. Arithmetic, even if they ask also, some kind of twist will keep. So if it is arithmetic increase method, x bar you have to find out. If it is geometric increase method, r bar you have to find out. If it is incremental increase method, both x bar and y bar you have to work out. If it is a decreasing growth rate method, so you have to work out d bar. If it is logistic curve method, 3 components you have to work out, ps, m and n, using population statistics, that population data. That's it. Nothing will be there. This is about population forecasting methods. So many other methods also there, but they are theoretical methods. So nowhere will get questions in exam like simple graphical method, comparative graphical method, ratio method, master plan method, something like that. So many theoretical methods also available, but not required for this exam. Okay, anyway, this is about population forecasting. Hope it is clear to you. Next, per capita water demand. Next, so once you know population, next step is you have to multiply this population with per capita water demand to arrive at future population, to arrive at water requirements of a community for which system is to be designed. What is per capita water demand? It is average amount of water. It is average amount of water demanded by an individual living in a community to meet all his day-to-day water needs. So whenever we design this water supply scheme, we not only supply water for public, we also supply water for different purposes. So there are so many sectors in a community, they also demand water. We try to supply the water to meet their demands as well, along with public. So public normally is a service sector. Almost we supply water at thrown away price. But when you only supply for public populations, public living in a community, no other sector if you supply, it is very difficult to recover back the investment. Isn't it? Public or service sector, therefore we supply at a very cheap price. Same price with only public if you depend on, then we never ever get back our investment, because municipal corporation invest millions of dollars in creating this system, or crores of rupees they invest in creating this system, water supply system, isn't it? So again they get back their money. Nobody will fund them. They have to fund themselves. So again system has to earn money to them. So therefore we not only supply water for public, we also supply for other sectors, but pricing is not same. See now, when Government of India supply gas cylinders to residential to individual residents, the pricing is different. Same cylinder they supply for commercial sector like hotels, restaurants, pricing will be different. Commercial sector they charge more. Residential sectors they will give some subsidies. For public they give subsidies. So the losses that they incur by serving the public, they recover that losses by supplying the same cylinder for commercial sector, where pricing will be different. So different dynamic pricing would be there. Same thing they supply for different pricing. Same way here also water. So it is not only we supply water for public, we also supply water for commercial sector, We also supply for water for industries. We also supply water for many sectors in a community. All that put together is called per capita water demand. Normally speaking, every demand we express in terms of per person water demand. So that's why it's called per capita water demand. So per capita water demand of individual, shortcut we can write PCWD. Per capita water demand or per capita water supply. So supply has to meet the demand at the end, ultimately at the end of the day. So per capita water demand, to work out what we do, we take total water requirements of entire community, right? That community includes domestic sector, industrial sector, commercial sector, all sectors put together including firefighting. So total, and moreover water requirements also vary from time to time. Whatever water we demand in winter, same demand would not be there in summer. Summer demands increases. Whatever demand is there in summer, same demand would not be there in rainy season. So demands vary from time to time. Demands vary from hour to hour. Demands vary hour to hour in a given day. Demands vary day to day in a given month. Demands vary month to month in a given season. Demands vary season to season in a given year. So therefore all these things we have to take into account. So it is very difficult to take all these things into account while working out. Therefore what we do is, so we take total water requirements of entire community, total annual water consumption. If you take total annual water consumption of entire community, that includes seasonal variation, that include monthly variation, that include daily variation, that include even hourly variation also. So therefore total annual water requirements of entire community, total annual water consumption of entire community. Who will give this value? Records will be available with you. Last year how much water the city has consumed, before last year how much consumed, like that 10-15 years average you take, you will get total annual water consumption of community. Community could be city, town or village, whatever it may be. By, so normally you work out this per capita water demand in terms of liters per person per day, in terms of LPCD. LPCD stands for what? The unit of this is liters per person per day. We write like this, LPCD. Shortcut we write LPCD. In the exam also, in question they will mention LPCD. LPCD stands for what? Per person water demand. We express in terms of LPCD. So per person you have to write the entire community host population. So divide this by population of that community. So this is annual consumption, daily consumption I require. Therefore divide by 365. Population of that entire community by 365 if you divide, then you get per capita water demand in terms of LPCD. So LPCD stands for what? Liters per capita per day. Liters per capita per day. Per person per day otherwise. Or you can also write here liters per person per day, or otherwise some people write as liters per head per day. All are one and same. So this is how we can arrive. So if you take this, you multiply this with the population of that community, you will get total water requirement of that community. So total average, total daily water requirements of a community will get. Average daily water requirements. Okay, I'll write like this. This is only our design Q value. Q is equal to, this is population of that community for which system is to be designed into per capita water demand. So population we can work out in terms of persons, per capita water demand we work out in terms of liters per person per day. Then what happens? Persons will get cancelled. We left with which unit system this is? So and so liters per day will get. but so large number you will get to, that's so uncomfortable to write here. So we'll get to this Q value in liters per day. So normally this Q we get in liters per day, but liters per day is too difficult to express here. We convert this liters per day into MLD. In India we write MLD. In US people calculate in MGD. MLD stands for what? Million liters per day. MLD stands for, so that small number will get million liters per day. So 1 MLD is equal to 10 power 6 liters per day. Therefore 1 liter per day is equal to, how to convert this into MLD? 1 by 10 power 6 MLD. So we got liters per day. To convert this liters per day into MLD, what you need to do? Q value, you have to multiply with Q value. If you multiply with 1 by 10 power 6, then you will get to Q value in MLD. This average daily water requirements of a community. Right? Understood? So normally MLD stands for what? Million. Million means 10 power 6. Clear now? In the exam also, in the questions they'll write mention 10 MLD, 20 MLD like that. MLD stands for million liters per day. Okay? But we don't design the system for average demand, we design for maximum demand. Therefore, we consider fluctuations in water demand. Daily fluctuations, hourly fluctuations. Some components of water supply scheme we design for maximum daily demand. Variations in water demand. Some components of water supply scheme we design for maximum daily demand. Maximum daily water demand of a community is equal to, I am talking about entire community, not individual, total community, for which system is to be designed. This is Q max, I'll write like this, daily is equal to, it is just multiply that average daily demand with 1.8. Okay, 1.8. Some Goodrich formula is there, that is not required here, no need of going. That empirical formula is proposed by different people. Just multiply average demand with 1.8. Suppose when you are designing a beam for 20 ton load, that is 20 ton load is service load or working load. But we don't design for working load or service load. We design for factored load. What is that factored load? How to arrive at factored load? By multiplying working load or service load with 1.5 or 2 or something like that. Exactly same way. Okay. Maximum daily water demand is equal to 1.8 times average daily water demand. So some components of, most of the components of water supply scheme we design for maximum daily water demand. Some components of water supply scheme we design for maximum hourly water demand. Maximum hourly water demand is equal to, so Q max hourly water demand is equal to, it is 1.5 times Q max daily water demand, or otherwise in terms of average you work out, it is 2.7 times average daily water demand. So remember these values sometimes. Of course, he is not asking in GATE exam, but the competitive exams, what is the factor to be multiplied to arrive at average daily demand to maximum daily water demand, average daily demand to maximum hourly water demand, something like that. So 2.7 times Q. Okay. Next, similarly, one more thing is there, coincidental draft. Coincidental draft. So while supplying water to the public at maximum rate, during that time all of a sudden fire accident occur in the community. So my system has to be addressed maximum daily water demand of the public, and at the same time fire demand also very important. First priority is given to fire demand. Suppose fire demand is not taken into account while working out the system, then what happens? You don't have space to accommodate extra water that require for extinguishing the fire. Therefore, that leads to loss of life and damage to property. Fire demand also one of the important demands we supposed to address. Therefore, that is also taken into account. Fire demand plus maximum daily water demand is known as coincidental draft. Coincidental draft. With mere coincidence, when public are drawing water at maximum rate, during that time fire accident break out in the community, system has to address simultaneously both of the demands together. So system should have enough capacity to accommodate water required for public and water required to extinguish the fire. So both of the demands we need to meet at a time. Therefore system should have enough space, enough capacity. So therefore sometimes some components of water supply scheme we design for coincidental draft. So coincidental draft is equal to, it is maximum daily water demand plus fire demand. Maximum daily water demand plus fire demand together known as coincidental draft. This fire demand we estimate by empirical formula. There are so many number of empirical formula are available. So using those empirical formula we work out fire demand. Fire demand estimated by empirical formulae. Okay, coincidental draft. There is one more demand known as total demand. Sometimes some components, draft is nothing but demand only. Draft is nothing but, it is a synonym for demand. Total demand. Total demand is nothing but, it is a coincidental draft and maximum hourly demand. Between them whichever is larger, that is taken as total demand. So it is total demand is equal to, it is coincidental draft or maximum hourly demand. Between them whichever is greater, whichever is greater, whichever is more, that is taken as total demand. Some components of water supply scheme we also design for total demand. So many components we design for maximum daily demand. This is very, very important. Nothing is mentioned regarding these variations which is designed for average demand. Generally in practice I am talking, not in exam. In practice we always take variations into account. We don't design for average demand, we design for maximum demand. Okay, sometimes for daily water, some components we design for daily water demand, maximum daily water demand. Some components we design for maximum hourly water demand. Some components we design for coincidental demand. Some components we design for total demand. So just have idea. Okay. So let us see what are the different types of demands that we have to consider while working out per capita water demand. So this is also not so important for GATE exam. This is based on IS. Based on IS code has recommended, because it is very difficult to find out per capita water demand, because the individuals living in a community, no two individuals are same living in a community. So no two people demand same amount of water. So it is very difficult to find out the per capita water demand. Therefore what we do, indirectly we work out all the demands and all of them we sum up. Finally we arrive at per capita water demand. Okay, as per IS code. This is IS 1146/1977. I don't remember exactly code year and all. IS code, as per IS code this is. So the following demands are taken into account to work out total water demands, per capita water demand. The following types of water demands are taken into account to arrive at per capita water demand. One is domestic water demand. Domestic water demand means what required for drinking purpose, what required for cooking purpose, what required for bathing purpose, what required for washing cloth, etc. Drinking purpose, individuals, cooking purpose, bathing purpose, flushing toilets, etc. So as per IS code, need not go details about this, right? Just that figure you have to remember. Minimum 135 LPCD we need to provide, and it may go as high as 200 LPCD. It may vary anywhere between 135 LPCD to 200 LPCD. Domestic water demand, which require for drinking purpose, cooking purpose, bathing purpose, washing cloth, cleaning utensils, flushing toilets, gardening purpose, all put together. Normally, the population living in a community, we divide them into three categories. LIC category, right? MIC category, HIC category. LIC means low income group category, right? MIC means medium income group category, and HIC means high income group category. So that means people living above poverty line, they are rich people. People living close to poverty line, they are middle class people. Below poverty line, they are called low income grade people. Okay, like that. So depending upon their what kind of people the community hosts, so depending upon that, per capita water demand depends. So most number of people are rich people living in a community, demands will be very high. Poor people are living in a community, demands will be little slow. So low income grade, normally it is 135 LPCD if you need to provide minimum. High income grade, it may be more than a 200, of course 200 LPCD provide. Between MIC and MIC people are more there, so anywhere between 135 to 200 you can provide. So in general it is 135 to 200 LPCD we supposed to provide as per IS code. If you provide anything more than that, we appreciate, but it should not be at any cost less than 135 at any cost for Indian towns and cities. Okay. So normally MIC we provide 150 to 200, anywhere between 150 to 200. $150 to 200 LPCD, slightly more than 135. Okay, for Indian towns, having with the full flushing system. With that partial flushing system is there, even less also. Okay, it is. So depend what kind of sewerage system is there in that community. This is called domestic water demand. And second one is industrial water demand. Industry also part and parcel of a community. Same water we supply for industries, but pricing is not same. Pricing is different. Domestic purpose, if I supply 25 paisa per liter, 30 paisa per liter, but same water we supply for commercial sector for different pricing. The pricing would be, right, much more than that. It may be 1 rupee per liter, 1.5 rupee per 1 rupee 50 paisa per liter, something like that. Therefore, more profit we can make. Therefore, industry also part and parcel of our system, community. So it demands vary from industry to industry. Dry industry consume less amount of water. Wet industry consume more amount of water. For example, automobile industry, if you take, the demand is very low. It may be 50 kiloliters of water is required, or less than 10 kiloliters of water is sufficient to manufacture one vehicle or any kind of automobile. Whereas if wet industry, like example is paper industry, it consumes huge amount of water. It may be as high as 300 kiloliters. 300 kiloliters of water is required for every 1 ton of raw material they use. Okay, it depends. So therefore industrial water demand, so it is very difficult to assess. It may vary from industry to industry depending upon the size of the industry also. For same industry, small paper mill consume less water, big paper mill consume more water. Therefore it is very difficult to assess. Therefore whenever we find such a difficulty, we just follow codal provisions. A minimum of 50 LPCD need to be provided to address the industrial water demands of the community. If you provide anything beyond 50 LPCD, it is well and good, we appreciate. But at any cost, it should not be less than 50 LPCD. Okay? And the third one is institutional and commercial water demands. Institutional and commercial water demands. So there are so many institutes around us, like schools, colleges, offices, social institutes such as temple, mosque, gurudwara, church. All of them are social institutes. They also need water. Commercial establishments like shopping malls, cinema theaters, right? Business centers, they also need water. Hotels, restaurants, they also need water. So they also depend on municipal. They also look at municipal corporation. They supply at a thrown away price. Even though pricing will be different, still it is cheaper for them. So therefore they look at them. A minimum of 20 LPCD need to be provided. If you provide anything more than that, we appreciate. but at any cost it should not be less than 20 LPCD. Okay. For GATE exam, this much idea is there more than sufficient. You don't require so much in-depth knowledge regarding this each and every demand. For that state government exam, they'll ask more questions from these water demands, but not in GATE exam. Okay. GATE more of numerical type. Institutional and commercial water demands, it is 20 LPCD. Then demand for public utility. Demand for public use, public utility. So there are so many number of facilities used by all of the public living in a community, like parks, right? Fountains, gardens, then government construction work, public auditoriums, public grounds. They also need water, isn't it? Playgrounds and all. So who will provide water to them? Public swimming pools. Who will provide water to them? Municipal corporation only. Therefore, a minimum of 10 LPCD need to be provided to address their water demand. This 20 LPCD, 10 LPCD, 50 LPCD is not small amount. Suppose 1 lakh population is there, 10 LPCD provide for public utility. So total amount of water we provide exclusively to meet this demand is 1 lakh into 10, it is 10 lakh liters. 10 lakh liters is not a small amount, isn't it? That's how we work out. So fire demand, as I told you, we work out by using empirical formulae. So I'll explain you. Fire accidents also common in a community. So whenever fire accident occur in a community, right, then immediately we need to address. It may vary anywhere between 4 to 6 liters per capita per day. By empirical formula we work out, but it may vary anywhere between 4 to 6 liters. I'll explain you in the next class how to work out fire demand in terms of LPCD. Okay. Next, demand to compensate loss and theft. I'll write in the next page. Okay, I don't have space here. Demand to compensate losses and theft. That is sixth one. So, what is supplied by using water supply system? Water supply system made up of pipelines. It's a piped water supply. So all pipelines are joined, small pieces are joined together because of bad plumbing, because of faulty joints, because of leakages. So much water get out of the system. That is called loss. Similarly, there are so many illegal water connections taken by the public without the knowledge of authorities. Public draw water from the water supply pipes. Unaccounted, unauthorized water connections. So many would be there in a community. Finding them is very, very difficult for us. Therefore, some water go like that also, so that is also taken into account. Demand to compensate losses and theft. That's called theft, unauthorized water connections. Unauthorized water connection is known as theft. It is also taken into account. A minimum of 55 LPCD need to be provided. It comes around 15% to 20% of total demand. In India, country like India, 15 to 20% of total demand only towards meeting this. See, now it is more than industrial water demand. So it all put together it is. So water loss due to leakages, water loss due to bad plumbing, water loss due to faulty joints, and theft, unauthorized water connections, water used by unauthorized people, drawing water from water supply pipes without the knowledge of authorities. All of them are taken into account. So all of them put together. So total water demand comes around, total per capita water demand come around 270 to 335 LPCD. Total per capita water demand it may vary anywhere between 270 to 335 LPCD as per IS code. If you combine all these things put together, total per capita demand is different, domestic demand is different. Domestic demand is 135 to 200. Total all demands put together is 200. So we take total into account in per capita water demand. So population into this you multiply, you will get average water demand. That you multiply with factors, you will get variations. So then you will arrive at maximum daily demand, maximum hourly demand. So using them we design the system. Clear? So today I'll stop here. I started late, 10 minutes late today anyway. So you want to join this course, you can take my you can take this code GATE Civil. You will get some concession, 10% concession you will get on this course. Kindly do join, kindly do attend all the classes without fail. Okay, thank you very much for your. Today I'll stop here. So tomorrow we'll continue. Tomorrow morning I'll be taking the class. Morning session I'll take the class. Morning 7:30 to 9 o'clock I'll take the class. I'll try to complete this topic, and as well as I'll start sources of water as well. So thank you very much.